Hi guys, I hope you are doing well. And this week's plan is to review for exam 2, and also we're gonna cover a new topic, but it is not gonna be in our second exam. And I will share this review with you and the lesson, and hopefully we're gonna have the second exam next week. That's why I want you to solve all these problems. If you can solve on your own before watching this video, that would be great. But you can do this at the same time, without looking at first, to the video, and you can try it on your own. And after solving on your own, and then you can come back and then you can see, what we did in the review. I'm gonna share the review questions with you. It is already on my course, you can download them and you can start solving them before watching the video, as I said. Okay, before starting the questions, I wanna remind you, what the rules, we need to remember, to be able to solve these questions. If you remember right, the main topic for the second exam is gonna be undetermined coefficient technique, right? So, sorry, I need to be careful. Undetermined coefficients. Okay, what was the rules we used to solve all these problems? So our problem is this, as you remember, right? Second order, constant coefficient, linear, and non-homogeneous, right? Differential equation. As you know, we will be using, two main rules, and then we call them, right, the GC1, general case 1. This rule was saying, if you have a function f of t, right, on the right hand side, in this form, t to the m, you can suggest that, right, this particular solution. So it is gonna be e to the RT times a m t to the m plus a m minus 1 t to the m minus 1 a1t plus a0. But I remember, right, there were some cases this general technique will not work. That's why, I'm gonna need an extra term here, right? That extra term will help me to solve these type of problem under the special case. What are those cases? Which they will help us, to remember, to determine what the S is gonna be. S is gonna be 0 if R is not a root of auxiliary equation. Secondly, S is gonna be 1 if R is a simple root of auxiliary equation, but S is gonna be 2 if R is a double root of auxiliary equation, right? That was the GC1. So now we remember that. We're gonna use in solving the review problems. The second rule, GC2, was about the similar thing when you have, right, the f of t on the right hand side, which was given in one of these forms, right? You might have the polynomial, and also you might have an exponential function and the derivative function at the same time. You might have, okay, the sine version instead of cosine version. In this case, I will offer a different function. Since I have the exponential, I need to have exponential. And since I have, right, the polynomial, I'm gonna have the polynomial. But since I have a trigonometric function, that's why, right, I'm gonna have, okay, similar expression for the sine part as well. Bm t to the m plus b1t plus b0 times sine beta t. Okay, by the way, I think we did a mistake here. That should be sine function, right? Sine beta t. Okay. But as you know, right, I'm gonna need an extra term, okay, for some cases. And I need to determine what the s is gonna be. S will be equal to 0 if alpha plus I beta is not a root of auxiliary equation. Secondly, S is 1 when alpha plus I beta is a root of auxiliary equation. That's great. But we said that, right, if you remember, there is not going to be any exception, right, about this extra term. From now on, there is no other rule except the GC1 and the GC2. GC2 and the GC1 and the GC2 are the main rules, okay, we need to use to solve the second order non-homogeneous differential equation. So every time you have the differential equation, second order differential equation, you need to check out if you need this extra term. There is no exception, guys, okay? Of course, sometimes there's gonna be cases, okay, you are not gonna need it, but there are gonna be sometimes that you are gonna need it in case s equal 1 or the 2. For the second case, as you see, right, there is not gonna be any third cases, s cannot be 2, since you cannot have the complex double root if you have the second order differential equation. Okay, we had some other rules you will remember, right? Look at the superposition principle. If you remember the last class we did, right? Superposition principle. It was about, right, this case. Let's say I have a differential equation, second order differential equation, but this time, right, I have two functions on the right hand side. Then what I could do, superposition principle says you can choose, right, different function corresponding with different functions, and then you can solve them separately, and you can combine them linearly, right, after solving each of them. That's what I'm doing here. Look at that. For the function f1, I'm gonna choose y1, and for the function f2, I'm gonna choose another, right, the particular solution, and then I will solve them, right, separately. Then I will combine in my YP. The fourth rule was this one. We use the superposition principle, right? But as you see, right, we always found out what the YP is. But the problem when we solve the, right, the differential equation is going to be the general solution. After using, right, the superposition principle, right, we derived general solution will be equal to sum of the particular solution and as well as the homogeneous part of the solutions. So this rule comes from the applying the superposition principle. If you remember, right, we did at the end of the class, at the end of the last class. So these four rules actually are our main rules. There is no other rule actually, right? There are no other rules. So you need to use just these four rules, okay, to be able to solve every problem when you are given the second order differential equations. As long as you have, right, these type of functions on the right hand side, since we are gonna see, we're gonna learn the variational parameters, and then you will notice that, okay, there are some cases you cannot use the undetermined coefficient technique. When could you use the undetermined coefficient techniques? When you have, right, these type of functions, elementary functions, like the cosine, sine, polynomial, exponential type of functions, right? In that case, you're allowed to use the undetermined coefficient techniques. But you are going to see there are some cases, right? We will see that in the examples. You cannot use undetermined coefficient technique. That's why you are going to need, right, some different techniques. Okay, these are the rules, okay, we are going to need to use for the undetermined coefficient technique. Now I'm going to start solving some problems, okay, for the exam review. As I said, I put these online at the beginning of the semester. You can download them, and then you can find the solutions as well. But I will try to complete the solutions, okay, in this review. Let's see. Okay, the first example. So let's say review examples. First example, y second prime minus 5y prime minus 6y, which is equal 17 minus 8. So I need to solve the auxiliary equation, as you know, right, to start for the particular solution. So it is r squared minus 5r minus 6, which is 0. And I can factor it out. Sorry, this is negative 6 times r plus 1. And then my roots for this auxiliary equation is going to be r1 is equal 6, and then r2 is going to be equal negative 1. And so my homogeneous solution is going to be c1 e to the 6t plus c2 times e to the negative t. I'm going to need to find out the particular solution, which I'm going to determine this way. Since I had already the polynomial, that's why I'm going to have the polynomial in the form of what I have on the right hand side. Also, I'm going to have an exponential function, but which I don't have. That's why, okay, you can just write it down in this way. But, right, you need to always have this extra term so that I can determine what the S is going to be. To be able to determine what the S is, right, I need to figure out if my R is one of my, right, roots. As you see, this is my R value, which is 0, but r is not equal, right, any of the roots I have in my auxiliary equation. So r is 0 is not a root of auxiliary equation. That is why, right, s is going to be 0. Great, right? That will simplify my job. So I can now continue without that extra term in this way. So y to the p, yp, just at plus p I should have. And I'm gonna follow my differential equation. So yp prime is gonna be equal a, correct? And yp second prime is gonna be equal 0. You will remember, right, from our classes, what I should do, I should multiply by the coefficients. Coefficients are gonna be this one, -5. If I multiply, it's gonna be -5. And then the coefficient for the first term is gonna be -6, right? Now I should add them. If I add the left-hand side, I will have yp second prime minus 5yp prime, and then minus 6yp. And then on the right-hand side, what I have, -5a minus -6 at plus b. It should be equal to the my right side of the equation. So from this equality, I know I can use, right, the polynomial equation. That's why, right, -6a will be equal 7, and then a is going to be equal -7/6. And also, the rest of the terms will be equal the constant term there, right? And then b is going to be equal -8 plus 5a and over -6. If I calculate this one, what would happen? So 5, -35 over 6